Good morning, everyone, and welcome from the coffee break again. This session is about, I think, one of the most critical topics in the aerospace thermoplastics field, and this is about how to industrialize these technologies that we are talking about. So in the previous roundtable, we heard about strategies and future challenges from our main OEMs, but now we are looking at how to bring these advanced technologies for thermoplastic materials from lab scale to a real factory scale in a serial production scenario. This is connected as well with next roundtable involving innovation in equipment. It's a key enabler for industrialization. So I'm very pleased to introduce our three experts who knows the topic from direct experience. And yes, they were selected because they have different point of view and they can share their perspectives with us. They are indeed people that represents who really, the people who really makes the industrialization happen. So Enrique Sanchez, good morning. Enrique is Manufacturing Engineering Director at Arnova Composites. He has over 30 years of experience in composites and has led many projects focused on taking advanced material into production. This is the important thing, to bring it to production. Then we have Raúl Arranz. Good morning, Raúl.
Good morning.
An R&D project manager at Acituri Structures with more than 25 years in the field. He has worked across R&D, testing, and process development for composites manufacturing. And we have with us Salvador Romero. Good morning, Salvador. He is Principal Research Engineer at Fokker in the Netherlands, and he's one of the leaders in situ consolidation and welding of thermoplastic techniques, and also a former colleague of mine in FIDAM. Welcome, Salvador, and thank you very much. Thank you all of you for being here today. And well, as you know, we have limited time, so we will try to keep the answers to the point to try to cover all the times, okay? Thank you. Well, let's begin with our first question. I would like, Salvador, if you can tell us, in the high-performance thermoplastic materials, could you please identify for us the key technical challenges involved in the implementation of these technologies within the aeronautical structure components?
Okay. Good morning. First of all, thank you very much, Sofia, for this warm introduction. It is my honor and a pleasure to be here today with all of you and also to share this roundtable with these great colleagues and professionals. And I would also like to thank FIDAM for giving me this opportunity. Regarding to your question, I think it's quite difficult to just define general challenges for all applications for thermoplastic, high-performance thermoplastics. It depends on the technology, it depends on the application, it depends on the market, it depends even on the company that is implementing the technology. So it depends on a lot of things. I think it would be very subjective if I just say challenges A, B, C without any kind of context. So I think it's better if I do the exercise to try to explain the main drivers of the manufacturing technologies in general and see how the thermoplastic technologies can fit in. Okay. Yeah. If we talk about main drivers, of course, the first one are requirements. So or like any other technology in any other field, a thermoplastic technology needs to meet requirements if it wants to be useful. So thermoplastic technologies has to produce parts and define processes that meet requirements. This is quite simple. And if we talk about requirements, I like to divide requirements in two different groups. We have what we call traditional requirements, or what I call traditional requirements, and let's say new market requirements. It's not a real division, of course. It's just a fictional division. But I like to do it for just tidying up ideas. Okay, if we go for traditional requirements, of course, the first one, mechanical performance. So we all know the test pyramid. We have at the bottom, we have coupon test. At the top, we have a full-scale test. And concepts like fatigue, fracture toughness, chemical resistance, all these acronyms that we all love, SLS, G1C, OHT, DCB, and so on. So at the end, the strength of the materials, the strength of the parts. And in this point, I don't think we have any challenge. No, honestly, I don't think so. I think thermoplastic or high-performance thermoplastic can be at the same level than other material and technologies that are currently used within the industry. So some points, the performance could be a bit better. In some points, it could be a bit lower. But at the end, if we go for a conservative way, we can say that we are in a tie. So it's more or less, let's say, level, at least. But at least we don't have a challenge there. Then if we go for the next requirement, of course, business case. For me, I think it is impossible to define an assessment of a business case without defining a target application. So we can compare thermoplastic with thermosets. We can talk a little bit about cost, mainly recurring cost. We can talk about, thermoplastic material is a little bit more expensive, but it needs less ancillary materials, and also it has less production environment restrictions. Thermoplastic cycles are at higher temperatures, but are a little bit shorter. So it's really difficult to say anything if we don't define an application. We have already heard today in the previous roundtables that there are different requirements for different applications and even for different markets. So it's really difficult. But somehow, from this idea, we can extract the first technical challenge for thermoplastic material, and is that we need to define a specific application for every specific technology. And I don't think it is a minor or a light challenge. I think it's a really, really very important challenge. So at the level of optimization that we have reached the aerospace industry, we need to know, we need to define the specific applications to the technologies. Okay, I think it's quite simple and it's just common sense. If we continue with the requirements, of course we are talking about the aerospace industry, so we need to go for quality. So we know porosity, we need to reach less than 100%, 200% of void volume. We need to have good NDI. But if we have the right parameters, it's really easy to reach this quality, right? Or not? Yeah, because keep in mind that thermoplastic materials are defined to do chain processes. They are defined to do processes made by sub-processes. For example, we can have consolidation, forming, welding. We need to have several different sub-processes in one line. We are changing the state of the material several times for a specific part. And in all these sub-processes, we need to know and we need to control the process parameters. So here we arrive to another challenge. We need to have a robust and reliable process control system that we need to use, and it's going to help us a lot in future steps. And of course, this process control system needs to be supported by a really good qualification plan. We need to relate the process parameters in the different steps of the general process to the final mechanical performance. It is key. For the next requirement, I'm going to try to run a bit industrialization. So we need to have a robust and repeatable process. And if we are in the case of having a global, homogeneous, uniform process, like press consolidation, it is really easy. But thermoplastics are tailored to do local processes. For example, welding or in situ consolidation, we are melting and consolidating the material in a local, specific, small area of a real part. And in this case, we arrive to another challenge. We need to be completely sure that we develop either technologies that are not sensitive to external deviations or tools that allows us to know what is going to be the impact of these external deviations into our performance. So we need to have these tools. And at the end, if we use this knowledge and these tools to relate them to the analytical and stress tools, it will help a lot on certification, on the final step of the development. Okay? Now, this is all about traditional requirements, and then we go for what we have heard today, the new market requirements. Okay? We have seen that we have a drastic change in the market. We have three different factors. We have the OEMs, the aircraft manufacturers, that are telling everybody that they want to produce up to 75, 80, 100 narrow-body aircraft per month. We also have a new player in the market. We have urban air mobility, these electric VTOL vehicles that are aiming to travel short distances. And the forecast for these vehicles is also up to 5,000 per year. And finally, the third factor is that the new propulsion systems. Hydrogen or even the new conventional engines, that they are more efficient, they are more powerful, but they are heavier. So we have three new factors in the market, and from these factors we can also extract some requirements. So for example, we all know we need to do even lighter structures because we need to leave space weight-wise for the batteries and also for the components of the new propulsion systems. We need high-rate production, we have heard several times. We also need a quality control process for this one. We need also a robust part and process and traceability control system. And of course, we need a robust supply chain. And from these requirements, I think if we go for the first one, lighter structures, I don't think it is a problem because we have already seen that the thermoplastics are tailor-made to do lighter structures. So we just have to see, I'm going to talk about my book, sorry. We have just to see the full thermoplastic torsion box made by Jicky and Fokker in Hoogeveen, that is 10% lighter and 20% cheaper than the thermoset version. Okay? So we don't have any challenge on making lighter structures. We just need to apply with sense thermoplastics. High rate, of course, we have a challenge. We need to do automation, automation, and automation. That's clear. I'm not going to go further on it. And if we talk about the other requirement that we see, I think, of course, we have a lot of challenges there, but they are not specific challenges for thermoplastic. They are general challenges for every technology that wants to reach these crazy production rates. So it's in general. Yeah, and sorry, I almost forgot it. Of course, we have a new big key requirement for the market, that is sustainability. We all know about capabilities of thermoplastics. They can be reused and recycled. But from our side, we need to see if it is real. We need to know the real reality of these technologies. We need to see if we can implement these technologies into a real production or a part or a production line. Of course, it's clear. From also business factors, just one, and I finish finally, that it's also really important if we want to move the reluctance to change, the reaction against change. The aerospace sector is based on thermosets and metals. If we want to move to thermoplastic, it is not a light change. It is a fundamental change. We need to change our mind. But it's not only a mindset change. It's going further. It is necessary to re-educate the industry, operators, engineers, managers, quality, authorities, stress and design, everybody. We need to, in the best of the scenarios, we need to refurbish the machines and the equipment that we have. And in the worst, we need to renew our machines and equipment. And of course, we need to build a robust supply chain, but not only material-wise, not only related to the materials, also related to the services, to the other companies that are around the industry. So it's quite important. So at the end, we are talking about cost. And also we have seen that we still have challenges from other requirements, so risks. Combination risk and cost is not a good combination. So, and also it's not what you want to tell when you want to sell a technology. So, no. So here is where the research centers, and mainly the research centers working at the highest tier levels, can fit in. They can help us on reducing the risks and reducing the cost for the implementation of these technologies. And just a final idea, if we want to reduce risk, it's also, I think it's also quite wise to start working or be focused on technologies that are at high level of maturity, because it will help, it will reduce the non-recurring cost, and it will help reducing risks.
Thank you very much, Salva, for this approach in which you make the difference between the traditional requirements and the market requirements. And well, wow, a lot of challenges connected with this last sentence. I would like to ask now to Enrique, from your point of view, now it's about processing technologies itself. What do you think, Enrique, which thermoplastic processing technologies demonstrate higher maturity level or greater potential application for being implemented in aeronautical industry?
Okay, first, thank you for having us. Okay, to answer this question, we must differentiate between today's maturity and true potential. Okay. First, simple stamp forming for clips, brackets, etc., such as we know today has shown a high degree of maturity and many parts are in service today. This is the simplest case of use and is normally based on the use of out-of-the-shelf sheets, what we call organo sheets. And the problem with this approach is that leaves no room for optimizations in the material format, does not allow thickness variation and drop-offs as we normally do in thermosets. This is not what we want if we want to go a step forward in the use of thermoplastic parts of high responsibility. We need to optimize laminates with variable thickness and with welded stiffness. So we see a high potential in stamping, which is probably the most basic of all the applications, if we are able to combine it with affordable and efficient lamination systems and with the use of welded stiffness. The combination of these technologies would allow a wider introduction of thermoplastic in relevant components, such as ribs, for example, for wings, stabilizers, movable surfaces, also frames, beams, cargo air struts, etc. Regarding these lamination systems, for these optimized flat preforms, first we have in situ consolidation. In our opinion, has two main concerns, and I think we are hearing a lot about in situ consolidation, but it has two main concerns. This is low productivity for the time being and the high level of investment requirements. Then we have fiber placement. Fiber placement systems are faster, but are also expensive and require a further compaction system. Okay, if you see from the point of view of a company like Arnova and probably Aciturri, at this moment we are not going to invest heavily in thermoplastic equipment until we have a contract or a real perspective of having a commercial contract. So we are going to be very careful with the selection of technologies due to economic constraints. So in this regard, we should aim to simpler lamination system, such as, for example, a kind of pick and place with spot welding, followed by a proper compaction system that could be faster and more affordable for us. Depending on thickness, this compaction system that we would need have to be flexible enough for different stacking configurations, and the systems could range from single vacuum bag in an oven to compacting presses. In fact, if we have time, we will speak later that we are now developing one of these compaction systems in collaboration with IGESTEC. I think they are here. And then speaking about welding, welding of stiffeners, we think that this is going to be one of the key enablers for reaching the same level of sophistication in thermoplastic and the same level of sophistication of the same parts in thermosets. I think that we really need to go this step forward. But from our perspective, and for us, it's not easy to evaluate what is the level of maturity of the different welding technologies. For example, induction ultrasonic resistance welding. The maturity of these technologies is now very concentrated on a few institutions and companies and a few actors. For example, probably the OEMs, and I don't know to what level, and also the Dutch colleagues. And for the rest of us, it remains it's a challenge to evaluate what is the maturity of these technologies and build up our knowledge and be able to evaluate which industrial solution will suit best our needs. So that's why we also need the advice of technology centers and experts. Mm-hmm. A comment about more complex structures as the big covers, skins, reinforced with stringers. And here we have probably, again, a limited perspective. We have seen remarkable achievements in the multifunctional fuselage and demonstrator, but it's still uncertain if thermoplastic components of this kind will be widely introduced in upcoming platforms. And this is not only due to technological maturity issues, it's also because of economic factors and the need to dramatically change the industrial footprint of our existing platforms. So all of us, we have a lot of autoclaves, ATL machines for thermosets, etc. And of course, we want to having them working for many, many years now. Other very interesting application is the substitution of fasten joints in assemblies with welded joints. This is again linked to the maturity of the different welding technologies, as we have already commented, and also to the specific development and adaptation of means for introducing this capability in assembly lines. I think a final comment about platforms. I think that it has been commented before, the opportunity that we have in the urban air mobility market. I think this is a great window that we have for the introduction of these structures and further develop the maturity of the process, demonstrate high rate capability, and also to demonstrate and show reliability in service.
Mm-hmm. Okay, thank you very much, Enrique. You have talked about processes, stamping, welding, automatic layup, a lot of processes. And now I would like Raúl, I think there is not much time, but I would like if you can tell us what steps is your company taking to implement thermoplastic technologies in the factories.
Yeah, sure. Thanks so much, Sofia, and thanks for the invitation. Well, I fully agree with my colleagues, and in Aciturri in the recent years, we are trying to learn about the technology, about the manufacturing processes, the different manufacturing processes. We launched more than 5 years ago a project that I think it was really ambitious due to the large size of the component that we tried to develop and the thickness variations that we were considering. including the welding, and we thought that the maturity of the technology was higher than the reality was final. And at the end, we continued this first project with other projects developing different technologies, stamping, in situ consolidation, rapid deposition, and working in the welding as we understand that is the big promise with thermoplastics, the possibility of joining parts without the use of mechanical fasteners, right? But the reality is tough. There is a main challenge from the industrialization point of view, that is the process parameters, the industrial means. As Enrique mentioned, the companies cannot afford to buy expensive machines in order to process the material. And another problem is the raw material supply. It's not as easy as the thermosets or the metallic materials, and it's really difficult to obtain the organoseeds, the tapes, and finally, as we identify with this first project, thinking in a solution similar to thermosets with different thickness is not as easy as thermoset solutions. Mm-hmm. So that will be. We are working in trying to identify what will be the first project that we can implement in our factory. But at this moment, the main point is to understand and know the technology the best that we can.
Okay. Thank you very much, Raúl. I think that we do not have time for any other question, but I would like to very brief summarize your speeches. At the end, industrialization of thermoplastics is not just about developing new processes, but it is about making them robust and repeatable and ready for real production. And that is the point, to make them reliable. And well, you have highlighted stamping, welding, automatic layup as key processes for making industrialization of thermoplastics happen. So nothing more from my side. I would like to thank you again for being here today and sharing your insights and your experience. Thanks to all of you for coming today. Thank you very much.